So in this section we will be discussing about the general reactions, that is the general chemical reactions of methane. The first type of reaction, that is the combustion reaction. Combustion reaction is the burning of an substance in presence of oxygen. So on combustion of methane we can form two types of product. If the combustion is complete combustion, then the product found will be carbon dioxide and water. In this methane, it reacts in excess of oxygen. Okay, oxygen is in excess, and so it completely combusts or does the combustion of methane to carbon dioxide and water. The oxygen is in excess, you can say, if oxygen is present in large amount. The next type is incomplete combustion. Here combustion occurs, but it is occurring in the deficiency or insufficient supply of oxygen. So it is said to be incomplete combustion. Here the product formed are different, that is methane on incomplete combustion, it will give carbon monoxide and water. So here will be found carbon monoxide. So here it takes place in insufficient supply of oxygen. Okay. In both the cases are exothermic reaction. So when these products are produced, with it some amount of heat is also liberated, as they are exothermic processes. Okay. So that is why only it is also used as fuel, because it produces a large amount of heat. This is the reason for it to be used as fuel. Okay, and it is used in natural gas. As I have said, natural gas contains major constituent is methane, and that methane, it on complete combustion, it will produce carbon dioxide and water. So here you can say that it is a cleaner fuel than the other fuel here, because the poisonous gases such as SO2, NO2, or the sulfide oxides and sulfur dioxides and nitrogen oxides are not formed. Okay, so it acts as a cleaner fuel, as it can be completely broken down into the components which are not that very pollutant as the other. So methane is regarded, or the natural gas is regarded to be a cleaner fuel. Okay. The next type of reaction, that is the halogenation of methane. Halogenation means addition of halogen. Halogen is added, and one or maybe more than one hydrogen can be also removed. So halogenation type of reaction, it is a type of substitution reaction where the halogen, it substitutes the hydrogen. Okay, it is a type of substitution reaction. Okay, the halogen, it will substitute the hydrogen. For example, CH4, when it reacts with halogen such as chlorine, okay, in the presence of diffused sunlight. Diffused sunlight means direct sunlight should not be put on this reaction, or in the presence of direct sunlight this reaction becomes very explosive. So we use diffuse sunlight, that is you have to pass the sunlight but not directly. Okay. Diffuse sunlight, and the product here, what it will be formed here, one hydrogen will be replaced by one chlorine atom. So here there will be found CH3 Cl plus HCl. Okay. So this is how we can do the halogenation of methane. Further, this compound form, that is methyl chloride, it can further be treated with chlorine in the presence of diffuse sunlight. Then again there will be formed HCl, and with it there will be formed CH2Cl2, that is methylene dichloride. Here diffuse sunlight will be. This is sold as methylene dichloride. Further, this methylene dichloride, it can react with Cl2 in the presence of diffused sunlight, and it will produce CHCl3, that is trichloromethane, or you can tell it to be as chloroform. This chloroform can again react with Cl2 in diffuse sunlight and form carbon tetrachloride, that is CCl4. There is formation of CCl4 plus HCl. Basically, the mechanism evolved here is the free radical mechanism. In this, due to the presence of sunlight, I'll just explain the mechanism in short. The chlorine molecule, it splits into chlorine radical in this way. This shows the free radical, and then the free radical, it reacts with CH4. Here it will produce CH3Cl plus again a free radical. Now the one free radical of the Cl, it will react with this hydrogen free radical and it will form HCl. In this way the mechanism is carried out. Now this was in the diffuse sunlight. If direct sunlight is applied, then the reaction becomes explosive. So in the presence of direct sunlight, if this reaction is carried out, then there will be formation of carbon and HCl. Sunlight, I can show it by H nu, and the product form will be carbon and HCl. Now the halogens, the order of reactivity of halogens will be, the reaction of fluorine, it will be very spontaneous, so you can say it very highly reactive. Fluorine will be highly reactive, okay, and iodine, it will react very slowly. So the order of reactivity of halogens for this halogenation reaction with fluorine will be highly reactive, then chlorine, then bromine and iodine. Iodine will be very sluggishly reacting with methane to form iodomethane. The next type of reaction of methane is, that is the nitration of methane. Nitration, this is also a substitution reaction in which one hydrogen is replaced by the NO2 group, that is the nitro. Here we can write CH4, that is methane, and nitric acid, HNO3. It will react at 400 degrees Celsius at 10 atmospheric pressure to produce nitromethane, that is CH3, NO2 and water. Okay. Now what happens in this reaction is that methane, it combines with nitric acid, that is OH, NO2. This OH, it combines with the hydrogen of the methane and it forms the product, and the nitro, it forms bond with carbon. Okay, so you can see if I write for methane in this way. So one hydrogen, it will be replaced by the NO2 group, and that is why it is said to be as substitution reaction. This hydrogen, it will combine with the OH, bond will be broken from here, and this NO2, it will form bond with the carbon. Okay, so it will form. So this is the nitration of methane. The next type of reaction is the catalytic oxidation. It is the oxidation in presence of catalyst. It is the catalytic oxidation of methane. Now it is used for the production of methanol commercially. Okay, here methane, it reacts with oxygen in the presence of catalyst, that is copper tubes, at 200 degrees Celsius and 100 atmospheric pressure. Then the product formed is methanol. Now here the methane and oxygen, they are passed at a fixed ratio. That is methane and oxygen, they are passed in the they reacted in the ratio 9:1. That is 9 parts of methane reacts with 1 part of oxygen, then it will form methanol. Or I can say if 9 ml of methane I am taking, then I have to take 1 ml of oxygen to form methanol. So these were some important reactions of methane. Now we will discuss the uses of methane. Used as fuel. Fuel is one of the most important use, that is in the natural gas. Secondly, source of hydrogen. Methane, when reacts with steam, it will form carbon monoxide and hydrogen. So it is used as a source of hydrogen. This hydrogen is used in many reactions such as in the formation of ammonia, etc. Third, used as source of carbon, which are used in tires as fillers. That is methane. This on strongly heating, it will form carbon plus hydrogen. This reaction is also said to be as the pyrolysis of methane, pyrolysis reaction. Pyrolysis is strongly heating of methane at 1000 degrees Celsius, and here it is heated in the absence of air. Okay, so here the decomposition of methane occurs and it is decomposed to carbon and hydrogen. Okay, this is the pyrolysis reaction of methane. Here the carbon which is formed, this is called as carbon black, and this carbon black is used as fillers in tires. Next, you can see the important use is it is used in the manufacture of various compounds, such as it is used to form chloroform, many commercial compounds. Okay, so used chemical compounds such as methanol, chloroform. So these are some important uses of methane.